let me finish up on this part. Made the mistake of moving everything when I was talking about something different. Okay, but there is an illustration in your textbook that shows what is described about the autonomic nervous system. Okay. So, two major divisions of the autonomic nervous system include the sympathetic and parasympathetic divisions of the autonomic nervous system. Okay? These two divisions of the autonomic nervous system work in balance to each other. All right? You get a nerve from the sympathetic and a nerve from the parasympathetic that goes to the same structure. For example, you got a parasympathetic nerve that will work on the pupils of the eye. All right, the pupils will be the opening that light goes through in the eye, in the very middle of the eye. But you also got a sympathetic neuron that works on the pupils of the eye, the muscles that will constrict or whatever. Notice that they will do the exact opposite thing. The parasympathetic nerve will constrict the pupils, make it get smaller in diameter, whereas the sympathetic nerve will dilate the pupils of the eyes, make it get bigger. Okay, and so they do opposite things and they work in balance to each other. During certain conditions, either the sympathetic nerves might predominate or have a greater impact, or the parasympathetic might have a greater impact. Now, in general, sympathetic nerves, okay, from this schematic, the little dots represent groups of nerve cell bodies. Remind me that the next time we have lecture, I'm trying not to include too much more at this point. But the dots that you see will represent groups of nerve cell bodies. So imagine that you got a lot of neurons represented here. And so this will be represented by a dot here and here. These are groups of nerve cell bodies. Then their axons are represented by these lines. Okay? Now, I need to define a nucleus versus a ganglion, and a nerve versus a fiber tract.
Professor, why is the parasympathetic all close to the brain while the sympathetic is all spread out throughout the spinal cord?
Good observation, but that's the way nature set it up. And so the sympathetic neuron, the sympathetic nervous system has their nerve cell bodies at these levels of the spinal cord, you know, from the thoracic or chest level on down to the bottom of the back level. But all of these are sympathetic neurons. This is where sympathetic nerves originate from, the spinal cord. On either side, above and below, Another name for on either side of the sympathetic would be parasympathetic, okay? And so the parasympathetic neurons have their nerve cell bodies outside of the sympathetic, above in the brainstem in some cases, and below in this region of the spinal cord, the sacral region. All right, nature just designed it that way. Now, but to explain what is said over here, on these drawings, this will represent the ends of axons, many axons, whereas the dot represents more nerve cell bodies. All right, if you notice the length of, let's do sympathetic nerves since I did that first. Sympathetic nerves have short preganglionic neurons. All right, a ganglion would be a group of nerve cell bodies that are located outside of the brain and the spinal cord. But if you had a group of nerve cell bodies within the brain or within the spinal cord, then that would be called a nucleus. I'm going to define those again, remind me to define those again. So notice that sympathetic neurons have short preganglionic fibers. So here are the ganglia represented by these dots. And this is a short line representing short preganglionic fibers that are synapsing on these nerve cell bodies. And the longer line coming away from the ganglion will synapse with muscles that accelerate the heart rate, the pacemaker of the heart. Sympathetic nerves will release norepinephrine onto the heart, and that will speed up the heart rate. All right. Let me stick to explaining what this is saying.